Hi, in this video we will be taking the sentiment analysis model we developed using TensorFlow and then deploy it for real-time inference. So basically, if you have not seen my TensorFlow sentiment analysis training video, then you can click the link on the top and you can check it out. But in the final model and the vocabulary file that is generated out of my previous model, in case if you just want to skip it and directly learn deployment, then I will provide the link of those model and vocabulary file in the comment section below. I said that in the last couple of videos for model deployment, I have been talking about various ways one can deploy a model. It can be in real time, it can be in near real time, it can be in streaming pipeline, or it can be in the edge of a device. There are multiple ways a model can be deployed, right? I have been covering in detail, talking about all the theory beyond model deployment, the challenges that one encounter and everything. It's a 7-part series, and in case if you want to have a look, I will mention the link in the video description below, so you can just go to the description, get all the link and watch it. Alright, now let's come back to this particular video. So what we are going to do in this video is we are first going to analyze our model pipeline. When we talk about model deployment, it's only not the final model. You may get a scikit-learn pickle file or a TensorFlow HDF file or a protobuf file, right? So that is only part of the model deployment. Your model is a combination of multiple pipelines. It can be missing value imputation, which are done outside of your scikit-learn or TensorFlow. It can be some kind of aggregation that you are done outside using pandas. So when we talk about deployment, the deployment you have to account for everything, not only the final saved model. And in this video, we are going to see how our deployment pipeline look for the sentiment analysis classifier that we built, and that's what we are going to see. And finally, what we are going to do is we are going to take the output of that particular sentiment analysis model and then create a template code so that we can do inference. We will also check doing some inference. We will see how well the inference generalizes. In the next model, whatever functions and everything we have built as part of in the next video series, as part of this particular video, whatever functions and whatever inference methods we build, we will just bundle it into a Flask application and deploy it in Flask and then scale using GUnicorn. That's what we'll be doing in the next one. And in the further video, we'll be deploying it on a container, on-premise as well as cloud. So let's get started with this. So if you see the model training pipeline for the sentiment analysis classifier we built, basically we took the Amazon mobile electronics review data set, which is part of the TensorFlow data set. We tokenized the words in the each and every review. So it had a review and it had whether like a rating from 1 to 5. We converted the rating 1 to 5 into positive or negative. Say like 1 to 3 is negative and 4 and 5 is positive. That's what we did. We tokenized the incoming data. So basically we broke the each and every review into individual words, and then we create encoding of the token. So we assigned a numeric value to the token, right? And finally what we did is, like, to make the token length even, what we did is we did padding of the reviews. Some reviews may be short, some reviews may be too long. So we have to pad the data so that it's even in size. So instead of doing like an fixed width padding, what we did is we did a padding of in the batches. So basically in the neural network model, when we train in mini batches. Our batch size of 128. So rather than saying like, okay, make everything to 5000 length, what we did is, based on the batch, we did padding batches. So for each batches, it will take the maximum size of an individual review and then apply the padding to all other reviews. That's what we did. And finally what we did is we trained kind of a classifier. We trained a kind of a neural network model, which is a bidirectional LSTM. We created an embedding layer. Then we converted the incoming tokens, incoming words into 128 embedding space, and then we created a LSTM layer. And finally, after we trained, we picked the best model. So we saw like in the second epoch we were getting around 89% accuracy. We picked that best model and then we save the model as HDF file. Right now what we are going to do as part of deployment, see, as I said, now if you take only the file, a final saved model and deploy it, you will miss all the previous step. So you also need to tokenize the data, you need to encode the token. So when you get an input review, the review will be in text, the model understands only numeric value. So you have to take and encode the text and finally pad the data. So basically, like the larger reviews, if you are doing in batches, but in real time it might not be required, but it always a best practice to pad the data. Since we ran padding for individual batches, we didn't have a fixed width, so we can determine our own padding size when we are doing inference, because the model has seen multiple padding sizes because of the batch based padding, right? So, and then finally you have the model. So all this have to be taken into production when you are doing it, right? Now this is how the model deployment. On the top we saw the model training. This is how the model deployment looks like. The input will be a review, right? And then you will have a REST endpoint over that where a end user will call with the review, and then you return back whether the sentiment is positive or negative. Now we have to load our encoding vocabulary. Now in the training pipeline, when you are doing the encoding, it will assign a numeric value to a particular word. You need that word. So you need to, so what we did is we created a vocabulary file and saved it. We are going to download that encoded vocabulary file and then load it in the training pipeline. Deployment pipeline. The next what we are going to do is that model that we saved, final model, that is also something we are going to load it in the deployment pipeline, right? Then after that, what happens, the incoming token comes in, we will do the token encoding. We will call this particular loaded model, and then we will do a token encoding. Then we will do padding of data. Then finally execute the loaded model. And then get the final output, and based on the final output we will return a response back whether it's a positive or negative sentiment. So this is what we will be doing the deployment pipeline. So let's quickly build the code for it, right? Now we exactly know what we need to do. We need to take the data that comes in the REST endpoint. We need to preload our encoding vocabulary and load model. See, remember these two, the loading the model and vocabulary can take time. So you don't want to do for each and every record that comes in. So you need to preload it before the Flask application starts and keep it, so that when the data, incoming data comes in, you are just doing the inference with it, the token encoding, padding and inference with it. So basically we will be seeing when we go to the Flask application, but for now let's build the code for it, functions for it that we can embed within the Flask application. That's what we are going to do in this video. So now both the model is in my is going to be in my drive, Google Drive, and I will share the link of the particular model and vocabulary, which you can try it out as well if you are not followed my TensorFlow sentiment classifier model and done the training. I have already so what this command is doing is it's from the collab, it's importing drive object and it's mounting my drive in the /content/drive directly. So once you run this, it will ask you to basically click on a link and verify your Gmail address. Now it's going to be your Gmail directory where your drive directory where you have loaded the models. In my case, I have loaded it, but if you want to download it, as I said, I will provide the link in the comment of this particular video. So I have already loaded that particular directory, and you can see these are the two models that we are going, these are the two files we are going to use. One is the sentiment analysis HD5 model, which is nothing but the neural network model and the trained weights it has. We will also go and understand the model. That is very important. If you take a XGBoost model, it is nothing but a bunch of decision trees. If you take an logistic regression model, linear regression model, it is nothing but a bunch of coefficients. Logistic regression model in turn has a final sigmoid layer which normalizes the score between 0 to 1, right? So you need to understand the model. The reason is when you do a direct deployment is fine. Sometimes you may want to take the weights separately and then completely rewrite in a different language altogether. So we will also try and understand how the model and weights look like, so before going on to building the code. So we are going to take this model, which is our trained classifier, and then we are going to take this token, which is nothing but the words and the numerical encoding that it has. So these are the two files we'll be using, right? Let me import TensorFlow. Let's quickly analyze the model first, and then before going into the code. So I'm importing TensorFlow and then TensorFlow 2.x. Let me quickly print the version and make sure I'm in the latest version. Yes, I am. Now what I am doing is, like, the sentiment analysis model HD5 file I am getting from my drive where I have stored that particular model, sentiment analysis model, and I am doing the Keras load model method. So tf.keras model load model method, which will load this particular model file and assign it to a model object, and I am printing the model output. Basically the final layer was an dense layer, right? So the model dot outputs, it will show the last layer of the model, that is a dense layer. If you see, it's a dense layer, and it is shape 1, which is predicting, it's a binary classifier which is predicting whether it's a positive or negative sentiment, right? And then the model dot inputs is basically the embedding layer. The input to the model is an embedding layer where we feed in the encoded tokens, and finally it will create a 128-byte embedding, and then we have multiple LSTM layers, and finally a dense layer, right? To see the entire model, you can do a model dot summary, and here you can see we had an basically embedding layer and a bidirectional LSTM layer, and then a dense layer, and I later added some dropout layer as well. So there are multiple dense layers over there, and finally you have a layer where it will return whether it will return a score, whether it's a positive or negative. If you remember, we didn't use the sigmoid function. The score will not be 0 or 1 year. Between 0 to 1 year, we used a relu function. Basically what we saw in my previous video is any negative number tends towards a negative review, and any positive score tends towards a positive sentiment, right? That's what we saw. So let's try to get the weights of the model. So when you print model.getWeights, it's going to show you all the weights of all the layers. So all the trained weights, whatever, like we train the model, it runs back propagation, and it sees like what is the right weights to update. So these are the final weights when you do a model.getWeights. If you want to go to a particular layer, you can do a model.get layer of index 0, which it will go to the 0th layer, that is the embedding layer. So basically you are assigning to the embedding layer, and then you can find what is the shape of the embedding layer. We know our embedding layer was 128 size output shape, so it's 128. But if you want to get the input shape also, what you can do is you do an embedding layer and do a get weights method. You do a get weights of it, and then do a shape. So it will tell you what was the input shape. So input shape is 73,740. That is the number of words that we had in our vocabulary, and that is converted into 128 embedding, right? So each word is converted into an 128 embedding vector. If you don't do a word embedding, and if you do an 1-hot encoding, basically you will end up in just like 73740 values, only one value set, and everything will be 0. So it becomes a very sparse vector, right? Embedding is a good way to save space, and it creates a dense vector for us. And also it learns the word representation better. In one of my previous video, I visualized the embedding layer and showed you how some similar words come close to each other. So basically it represents the word in the vector space. Similar words are represented closely. In case if you have not seen the video, you can click the link on the top and you can watch it, how to visualize the word embeddings, right? Now, so I can similarly get the next layer 1, which is an LSTM layer, and then here you can get the output shape of LSTM layer. It is 256. It is actually 128 we had given, but it's a bidirectional LSTM, so it's 256. You can get the weights of that as well. Now this is how you need to, if you want to go and understand how the model is and what is inside the model, you can run this method. You can do for each and every layer. If you want to go and pass the data to a particular layer and see how it behaves, you can do that as well. What you can do is you can load that layer and then pass your value and see how the output behaves. So it gives you better understanding of your model. So tomorrow if you want to go for interpretation, we know neural networks are black box model, but this is a good way to understand your model better. It takes time and effort, but at least move towards having some interpretation to your output. Right now, let's go to the brand builder deployment code. So here if you see, what we are doing is we are loading the TensorFlow dataset and TensorFlow, both the model. The TensorFlow dataset is where the token method is there, the token encoding method which we used, and then the TensorFlow is where all the regular Keras load model and everything is there. So we are going to import these two, and this from this part on is what we will use to build our Flask application. Right. So for now, let's just run it in a standalone mode. Let's test it out, how our model behaves, whether our model is done properly. You need to see one important thing is when you're reproducing an production pipeline for production deployment, you need to test the pipeline before deploying it. You need to make sure all the pipeline is replicated properly, and that's what we are doing now. And then what I am doing is I am loading the model as I did in the previously, and also I am loading the loading my encoded file. Which is the other file which has the vocabulary for it. If you see the pipeline I had, so basically this is the pipeline. I had an encoding vocabulary. I am loading that one. I loaded the model. These two things. So these two things are the one which I have to load. Now I have to do the remaining part. I need to do token encoding. I need to do padding and everything. So for that, what I am doing is I am creating two functions. So the function takes in the vector, that is the encoded value, and then it takes the size, what I want to pad with. So these two values, and this function, what it will do is it will kind of extend the extend that particular vector with a zero padding to the right hand side. So that's what it does. So this function is going to pad based on the size we give. And as I said, we didn't do a fixed width size. It's a variable size, so we can, because our model is also trained for multiple paddings, you can define your own padding size depending on what input you will be getting and what you are fixing it out. The next one is we are creating a predict function. This function is going to do the major work. The predict function takes the text, the sentiment for which you need to see the sentiment. It takes the reviews, right? And then it takes the size we want to pad with. The first thing it does is we have loaded the text encoder file, right, which is has all the encoding. It calls the text encoder.encode method and then gets the predict text over here. So the incoming text, which is string value, will get converted in a numeric value, and that numeric value is based on the encoding that was assigned during the training. Because this model is from the training, so it was assigned during the training. The next what we do is we take that encoder, we take the final output and pad it all across, and the pad size is again via whatever we are passing, right? And then what we are doing is we are just casting it to int64 just to be type safe, right? We are just casting it to int64, and then what we are doing is we are predicting it. We are passing the encoded text over here, and then basically we are picking the basically we are expanding the dimensions, and then we are passing it to the model.predict method, and it will return the prediction, and we are returning the prediction over here. Again, as I said, the prediction will be between negative to positive value. I need to add one more method here, if which will add during the Flask application. The method says like if the prediction is less than 0, then it's a negative sentiment. If it is greater than 0, then it's a positive sentiment, right? I just want to kind of include that when I am doing the prediction as well. Let me run this as well. Now I've done this. Now what I'm doing is our model was trained on mobile electronics data, right? And we saw basically when we inferred with mobile electronics data itself, it was predicting decently, pretty well. In fact, it was like a 89% model, and most of the predictions that we did were right. Now what I'm going to do, I'm going to completely go out of the way, and rather than taking the mobile electronics, I'm going to take book review. And if you see here, why is it important? Your sentiment analysis model is built on a corpus, and there are a lot of words that may be very relevant to mobile electronics, may not be relevant to book, or may not be relevant to restaurant as well. So as you feed more and more data from multiple sentiment, you get a classifier that will generalize better. But as of now, it can be task specific, but I want to see how well it generalizes to reviews outside of mobile electronics. That's what I'm doing here. So here I'm taking a book review. What they are telling, unfortunately, this product did not come with CD, nor did the pages go in order. So it's a kind of negative review, and I am calling the predict function. with the padding size as thousands. That's what I'm doing. Let me print the prediction and see whether it understands a negative review. So it is telling it's a negative review, and we see the magnitude of the negative value specify the strength of the sentiment as well. So in this case, maybe the review should have been 1 or 2, not 3 actually, because 1 to 3 is negative for us and 4 and 5 is positive for us. That's how our model was trained on. Let me go to the next one. If you see, this is an tricky one, right? Both the original content and the additional content in this edition are great. It says it's great, but then it's however the additional content added at the expense of chapters and appendix, which is not included CD to access. So if you see, finally, when it's a very long review, and finally it says, okay, it's annoying to have to switch, but the missing chapter to be removed almost at random, and finally they say like it's actually worse than reading the normal ebook. So this kind of going to be, if you see, really okay, when you talk about computers to understand, it can interpret it anyway, because if you take the starting, it's positive. One good thing about neural network is it understands the context also, and you see again it's telling it's a negative sentiment, but the intensity is not as bad as the previous one, right? Now let's work with some positive sentiment. So here what I'm doing is, I just taken a positive sentiment. I is still working my way out. It definitely changes the view of investment. Wish it was available on Audible. So let me quickly run it, and then you can see it's a positive sentiment. Now it's a positive value, it's a positive sentiment. Now I took Amazon Books a review. I just copy pasted. I went to their website, copy pasted 2-3 reviews and put it here. Let me go completely outside of it. In this case, I went to Yelp restaurant review and I picked couple of reviews. So in this case, if you see, it says the consistent is a service and quality of food. The items were we've tried, we have tried, have always been very tasty, cool ambience and vibe, right? So it seems to be a positive review, and see the model also played a positive value, but since some of the words it was not able to correlate it. The tasty, usually mobile electronics review will not come tasty or very tasty. So some of the words, so it was confused, but still it went to a positive review. That's why if you in this case, if you train from Yelp data set, if you train from Amazon data set, if you do everything, your model may generalize better. But in this case, it's fine. It's still positive review. Let's see one negative review of restaurant. The reason I'm showing this is when you're putting in production, you need to understand your model in this case can understand only the data distribution or the vocabularies that is sent in the training set. So make sure you need to have a lot of training set to generalize better. So in this case, it's doing its job, but it may not be perfect all the time, right? So it says I sat there for 10 minutes and never got offered the menu or anything. We didn't get any kind of attention. So even though there were 3 customers, it's kind of a negative review over here. Let's see how it predicts, and it's pretty negative. So even though it has not seen any of the restaurant review, it kind of generalized because of the words, how the words are arranged and everything. Right? Maybe if I created a bag of model in this case, it might have not been able to generalize as much as a neural network model, which understands the context of the word as well. So now what we are going to do in the next video is, we are going to take these 4 lines and then also add some additional one, and then we are going to build a Flask application, and then we are going to deploy it as Flask, and then we are going to use GUnicorn to scale it. Now I have a separate video of why we need GUnicorn and Nginx with Flask. I have a separate video on containers. For Nginx video, you can watch the link on the top, and you can see like why do we need it. So I'm not going to go into the details of why do we need GUnicorn with Nginx, so GUnicorn with Flask, but you can watch it and you can understand it. And I will give a small mention in the next video as well. But that's it from this video. So let's go to the let's come back in the next video and deploy it in a Flask app. Thank you.